Okay, these are the 2003 free response questions about vector functions and associated stuff. Right, we've got a particle starting at point A on the positive x-axis at time 0. It travels along the curve from A to B, where it looks like it has a place where it would not, where dy dx does not exist, sharp point, then to C, and then to D. Coordinates of the particle's position are differentiable functions of t, where x of t is equal to x prime of t is equal to this big mess, and y prime of t is not explicitly given. At time t equals 9, the particle reaches its final position. Let's just write that in here. That's at time 9. This is at time 0. And, all right, away we go. So at point C is dy dt positive. And at point C is dx dt positive. Well, that's easy. This is about what direction it's moving, right? Dx dt is positive if something is moving up, and if something's moving to the right, this is the positive direction of the x-axis. So you have a positive x velocity if you're moving this way, negative if you're moving that way, and likewise for y, up and down. So at point C, dy dt it's going this way, right? They told us this is time 0, so it's flowing this way. So C, at time C, it looks like the y is decreasing, and so is the x, right? And y is getting smaller, and x is getting smaller. So dy dt is less than 0 because particle is moving down. And dx dt is less than 0 because the particle is moving left. All right. Part B, the slope of the curve is undefined at point B. At what time t is the particle at point B? Well, undefined, dy dt over dx dt, that's how we find slope, right, when we're doing parametric stuff. So this is undefined when dx dt is equal to 0, right? When dx dt is 0. So here's dx dt. Let's set it equal to 0 and find where that happens. So we got to graph that horrendous looking thing. So let's clear that. So negative 9 cosine of pi x over 6 times the sine of pi times, who makes up these crazy functions? X plus 1, it's all that stuff, over 2. Alright, that should be it. And don't just automatically hit graph, that's not a good idea. We were looking from times 0, from t equals 0 to 9, and we're looking for where this is equal to 0. So where does this cross the axis? Boom, right there. Oh, it doesn't actually cross, it just grazes it, looks like. So just be careful. Looks like it happens at 3, but I'm going to make sure that that's true. Actually, do we even need to do that? Because I think we could probably justify that. I should think we could probably justify that it's 3 because it's cosine 3. That would be pi over 2. Right? That would be pi over 2, and cosine of pi over 2 is 0. So that's at 3. You can find it with your calculator. You find the maximum. So that happens at time 3. And that's not a 3.000, that's exactly 3. So you don't need decimal places there. Okay, that makes sense. Time 0, that's time 3. Don't know about that yet. And then that's time 9. Okay, the line tangent to the curve at time 8 has this equation. Find the velocity vector and the speed at this point. All right, what does that mean? This means at time 8, the slope, that's got to be dy dx, right? dy dx is equal to 5 over 9. right? But dy dx is also equal to dy dt over dx dt, and I have an expression for this, right? That's equal to that big mess, dx dt at 8, and then over dy dt at 8. So I know this fraction, I can figure that out, and so I can solve for this, and that'll give me the missing, what's dy dt, and then from that I can get the velocity vector and the speed. So I think I need to figure out what this is. What's dx dt at 8? So what did I graph here? This is dx dt, isn't it? So I've already got the graph of that. Awesome. So I can just go back to that graph and do second calculate. I want the value of that at 8. And that's equal to negative 4.5. Oops. Negative 4.5. So now I've got this. I've got 5/9 is equal to negative 4.5, and then the dy dt here on the top. So it looks like that would have to be negative 2.5. You can do a little algebra there if you want, but this is twice as big and negative. That's negative, so dy dt is equal to negative 2.5. So the velocity is negative 4.5 comma negative 2.5, and the speed is the Pythagorean theorem on that. So that would be the square root of 4.5 squared. I'm ditching the negative signs because I'm squaring everything, so it's just asking for trouble to include those. Speed is 5.148. All right, I'm just scanning back through this to see if there are any units, and it doesn't look like they give units, so I don't need to put units on my answers. Okay, last part. How far apart are points A and D, the initial and final positions, respectively, of the particle? Well, I notice a couple things here. Notice that at those points, A and D, the y position is 0, right? And does that actually help? Since we don't know anything about dy dt, that's not actually going to help, is it? So let's see, how far apart are those? How shall we figure that out? What information do we have that will get us that? We know that at time t, oh, we can do the, so we want to know how far it's traveled in the x direction only, right? So to figure out that distance only in the x direction, we can know that, we don't want total distance, we just want displacement, right? We want displacement in the x direction. And remember, displacement in one dimension, since we only care about the x direction here, that's equal to the integral from wherever to wherever, so 0 to 9 of this crazy expression. I should have just written x prime of t here. Sine of pi. Right? That will give us the displacement, right, from wherever to wherever. And we would expect actually the displacement to be negative, right, since I went from here to here. And but they just want to know how far apart are they. So we'll give the positive version of that answer. And that actually should be pretty easy to get also, because I still have in my graph, I still have that, so I can just do second calculate and go to number 7, do that integral from 0 to 9, And calculator will do its little shading thing. If you would have got the same thing if you had done total distance traveled, you would get the positive version of this. But in fact, we do want, if there were any loops back and forth, since we only want to know how far apart those points are, we really did want displacement. So it looks like they are 39.255 units apart. 39.255 units. You don't have to write that. That's how far apart they are. All right, that was a little faster than the other ones. And last one, we've got a particle moving in the xy plane. That's its x position. This is, oh, notice also this is a number 4. This is a no calculator problem. No calculator is allowed. They want the velocity vector in terms of t, and the and to find the speed at time 0. The speed. Okay, so part A. We want the velocity vector in terms of t. So the velocity at time t is equal to this vector. The x-coordinate would be x prime of t, which is 6e to the 3t. Forget about the chain rule. Minus 7e to the negative 7t, comma, y prime of t, which would be 9e to the 3t, plus 2e to the negative 2t, right? The chain rule played a big role in finding those. Okay, there's the first part. That's a velocity vector. And then they want the speed at time 0. That's the Pythagorean theorem on this. So velocity at time 0 would be, let's see, 0 plugged into this would be 6 minus 7, which is negative 1, comma, 9 plus 2. So speed is square root of 1 plus 121, which is the square root of 122. There's no calculator, so I'm just going to leave it like that. Right? Because e to the whatever 0, that's all e to the zeros. So I think that looks good. Now in part B, they want dy dx in terms of t. Well, that's easy because I have dy dt and dx dt, sorry, right there. So dy dx is just equal to this over this. That's 9e to the 3t plus 2e to the negative 2t over 6e to the 3t minus 7e to the negative 7t. And then they want the limit as t approaches infinity of dy dx. Well, let's think about that for a second. As t goes to infinity, these are going to blow up to infinity. What happens to these? That's going to be like e to the negative infinity, right? Which is like 1 over e to the infinity. So these two pieces are actually going to go to 0. So this part is going to go, this and this will go to 0. So these are the parts that actually matter here. And since it's 9 of those and 6 of the same thing, it's just those coefficients, 9 over 6. All right. C. If you're thinking about like would L'Hopital's rule work there, I think that actually, since the e to the whatevers are going to stick around, it's not going to work. You're going to have to actually just think about that one. C. Find each value t at which the tangent line to the path of the particle is horizontal, or explain why none exist. For the tangent line to be horizontal, we need the top of this to be equal to 0, right? That's tangent lines are horizontal when the slope is 0 and fractions equal 0 when the top's 0. So that happens when 9e to the 3t plus 2e to the negative 2t is equal to 0. And that ain't never going to happen because this 9 times e to the 3t. E to the 3t is always a positive number, and e to the negative 2t is still always a positive number, although it can get very close to 0, right? Because an e to the whatever graph looks like this. So it's always positive. So this is not going to ever be equal to 0. Positive number plus positive number equals 0. No solution, because 9e to the 3t is always greater than 0, and 2e to the negative 2t is always greater than 0. So that cannot happen. Part D, we get vertical tangent lines when the bottom's equal to 0. That happens when 6e to the 3t minus 7e to the negative 7t equals 0. And that can happen because I've got positive minus positive. And we want to find the value of t where that happens. So let's see if we can solve that. This is no calculator, so we actually have to do some work here. Let's see. I've got 6e to the 3t equals 7e to the negative 7t, and let's divide the 6 over here and the e to the negative 7t over here. So that would give me e to the 3t over e to the negative 7t is equal to 7 over 6, right? And e to the 3t over e to the negative 7t, that's actually e to the 10t, right? Think about that. That's actually like an algebra 1 exponent rule. E to the 10t is equal to 7 over 6. And then if I take the natural log of both sides, that'll make the e go away. So that gives me 10t is equal to the natural log of 7/6, or t is equal to the natural log of 7/6 over 10. All right. That's where there's a vertical tangent line. All right, those went a little quicker than the last ones. Awesome.